channel. So today we derive the expression for time period using dimensional analysis. This is the second part and the final part of units and dimension. So the question is, time period of the simple pendulum depends on the length of the pendulum, that is L, and acceleration due to gravity, that is small g. We have to derive the expression for time period using the help of dimensional analysis. So first what we have to do, the time period of the simple pendulum depends upon two things. One is the length of the pendulum and the second thing is acceleration due to gravity. So we can write the time period of the pendulum depends upon length of the pendulum, that is L. We can write L to the power A. जेहेतु हमें डायमेंशनल एनालिसिस करूचे, we can write that T is depend upon L to the power A. Time period हमने T, so T is directly proportional to L to the power A. This is my equation 1, and T is directly proportional to G to the power B. Here G is my acceleration due to gravity. We know that simple pendulum perform a simple harmonic motion. Here this is the simple pendulum, and it will perform the simple harmonic motion. यदि हम रेट, दिस इज माय सिंपल पेंडुलम को यदि ए डायरेक्शन में रोटेट करी, पेंडुलम को करियो किस टाइम पर अपोजिट डायरेक्शन में मूव करियो एंड परफॉर्म द ऑसिलेशन मींस टू एंड फ्रो मोशन परफॉर्म करियो. से पर्यंत पेंडुलम ऑसिलेट करते देखो मतलब रेस्टोरिंग फोर्स 0 नॉइज. जेते रेस्टोरिंग फोर्स 0 हे जो पेंडुलम ऑसिलेट करे बंद कर दो, तापर पेंडुलम कोन जंप स्टॉप हो जाए. सो हमको गोटे एक्सप्रेशन बाहर करे अछि फॉर द टाइम पीरियड. मींस हम पेंडुलम टा लेट दिस इज माय मेन पोजीशन, ए पोजीशन में आसी पूरी ए पोजीशन में पहुंचे में कितने टाइम लगेगा, दैट इज द टाइम पीरियड ऑफ द सिंपल पेंडुलम. सो हमको एक्सप्रेशन बाहर करे अछि टाइम पीरियड ऑफ द सिंपल पेंडुलम. सो आई कैन राइट T is directly proportional to A to the power A and T is directly proportional to G to the power B. Combining equation 1 and 2, I can write combining equation 1 and 2, I can write T is directly proportional to L to the power A and G to the power B. So this is my equation 3. Now writing the dimensional formula of each and every term. It is our time period, length and G was our acceleration due to gravity. Individual term रे हमें dimension लिखो. So writing the dimensional of individual term. So I can writing the dimensional formula of every term. In equation 3, that is here T. So I can write the dimension of T. T dimension is m0, T to the power 1. Next, एक हमें proportional रूप से constant multiply करें. T is equal to k into L to the power A and G to the power B. So this is my equation 4. Writing the dimensional formula of every term in equation 4. That is equal to k whole into length. L is the length of the thread, so the dimension is m0, L1, T to the power 0, L to the power A and G. G is here acceleration due to gravity. Acceleration dimension क्या acceleration due to gravity रा dimension समान होगा. So I can write m0, L1, T to the power -2. Now multiplying A, so m0, L0, T to the power 1 is equal to k whole into m to the power 0, L to the power 1 into A, L to the power A and T to the power 0. Here is m0, L to the power B and T to the power -2b. So in the next step I can write m0, L0, T to the power 1 is equal to k whole into m to the power 0, L to the power A अच्छी B अच्छी With the power multiply, it was add equal, that is L to the power A plus B and T to the power minus 2B. Now equating the term of A male T from the LHS left hand side and the right hand side, I can write here. এটি m র পাওয়ার 0 সেটি m র পাওয়ার 0 আছে, এটি l র পাওয়ার 0 সেটি l র পাওয়ার কত আছে a plus b. So I can write a plus b is equal to 0 and minus 2b is equal to plus 1. যদি minus 2b আমার 1 হলে তাহলে b কেতে হবে? So I can write b is equal to minus 1 by 2. I can find the value of b. Then for the value of b, a plus b is equal to 0. So a plus minus 1 by 2 is equal to 0. So a is equal to plus 1 by 2. So a and b ର value ଆମେ ବାହାର କରିଦେଲେ. Now putting the value of a and b in equation 4. Now putting the value of a and b in equation 4, I can get t is equal to k into l to the power a, that is l to the power 1 by 2, g to the power b, g to the power minus 1 by 2, that is t is equal to k into l by 0 root over. This is the final expression. Coming to the next question, a force F is given by F is equal to a into t plus b into t square, where t is the time period and what is the dimensional formula of A. Equation found is it. So equation is F is equal to a into t plus b into t square. By means of dimensional analysis, we have to find the dimension of acceleration. So the dimension of F is force. So I can write the dimension of force, that is m0, m1, l1, t to the power minus 2. So if F is equal to a into t, then a is equal to f by t. So the dimension of F is m1, l1, t to the power minus 2 divided by time period, that is t. So the final expression is m1 l1 t to the power minus 2 minus of minus 1, that is equal to m1 l1 t to the power minus 1. This is the dimension of A. The second question is E is given by mgh plus half mv square. Here m is the mass of the object, g is the acceleration due to gravity. The question is, we have to check the correctness of the given equation. In this equation, here p term is there. This is my first term, this is second term, and this is third term. We have to find the dimension of every term individually. So first, find the dimension of E. Here E is the energy. So I can find the dimension of E is. So dimension of E is m1, m2, t to the power minus 2. The second term is mgh. Here m is the mass of the object, g is acceleration due to gravity, and h is the height. So I can write the dimension of mgh. Mass is m to the power 1, g is acceleration, that is l1 t to the power minus 2, and height is the length, that is l to the power 1. So combining these three, I can write m1 l2 t to the power minus 2 mgh. Then the third term, half mv square. We we know that half is the non-dimensional constant. So there is no dimension of 1 by 2. We have to find the dimension of mv square. So dimension of half mv square. 1 by 2 is the non-dimensional constant and v is the velocity and m is the mass of the object. So I can write m0 m1 t to the power minus 1, that is whole square, that is m1 m2 t to the power minus 2. Since the three terms have same dimension, here वाला m1 m2 t to the power minus 2, m0 is also m1 m2 t to the power minus 2, and half mv square is also m1 m2 t to the power minus 2. Since the three terms have same dimension, so this is a dimensionally correct equation. Coming to the next question. The next question is, if energy is expressed as k into v, then find the dimension of k. So E is equal to k into v, where E is our energy and v is the velocity. So I can write k is equal to E divided by v, but v multiplies to v divided by 0. So the dimension of energy. So the dimension of energy is m1 m2 t to the power minus 2. Dimension of v, that is velocity, I can write the dimension of v, that is m0 m1 t to the power minus 1. So k is equal to E by v, that is equal to m1 m2 t to the power minus 2 divided by m0 m1 t to the power minus 1. So here is m to the power 1 minus 0, l to the power 2 minus 1, and t to the power minus 2 minus of minus 1. So the final expression is m to the power 1, l to the power 1, t to the power minus 1.